Welcome back to another exciting day of Algebra 2. Today we are going to be looking at key features of graphs. So if you need to pause and fill in these definitions, you are welcome to, but domain is our x values and we list them from left to right. Range is our y values and we do list those from bottom to top of our graph. A minimum is a smallest y value and a maximum is your highest y value. So if you're looking at like a parabola, usually that's where your vertex is, but not every graph is going to have a minimum or a maximum. An x-intercept is where the graph crosses the y-axis. Again, not every graph will have one. Same story for a y-intercept where we cross the y-axis. An asymptote is a line that the graph never touches. It just gets really close to. Again, not every graph will have one of those. An axis of symmetry is a line where the graph is split into identical halves, also not going to be on every graph you see. And then increasing and decreasing is when we're looking at if our y values are going up or our y values are going down. And what's confusing about these intervals is we're looking at the y values to tell us if it's increasing or decreasing, but our answer is going to be over what x values is that taking place. So we are going to list all of the key features for this graph right here, starting with domain. It is infinite in both the left and the right side, so that is all real numbers, or negative infinity to positive infinity in both of our notations that we've been practicing. And then our range, I'm going off to negative infinity and it stops up here at positive 3. So y is less than or equal to 3. I get to underline it because that solid line is considered a closed circle. And then as an interval, that would be from negative infinity to 3. Infinity always gets parentheses. The bracket is here because it correlates with my underlined inequality. Looking at where the vertex is here, that is the highest y value, so that is a maximum. We do not have a minimum because it's going off forever to negative infinity. So that point is at the coordinates negative 2, 3, but the maximum value is where y equals 3. So those are the coordinates of your vertex, but this is the maximum value. X-intercept, where do we cross the x-axis? That is actually in two places here, at negative 5, 0, and at 1, 0. Y-intercept, we do have one. It is up here at 0, 1. I do not have an asymptote. I do have an axis of symmetry. I know this graph doesn't look symmetrical, but remember this is going on forever in that direction. So if I were to cut my graph in half through the vertical line that goes through my vertex, and I folded this over, I would have all my matching pieces lining up with each other. So my axis of symmetry, which I'll just abbreviate with AOS, is this vertical line, x equals negative 2. That's your axis of symmetry. Okay, and then lastly our increasing and decreasing intervals, and I can't spell increasing, decreasing. So the way that you can figure this out is imagine someone is walking on your graph, and we go from left to right. If they are walking uphill, that is increasing, so my graph starts at increasing, and then at my vertex we switch to downhill or decreasing. So the way that I describe over what intervals that is taking place is the x values because I am moving from left to right. So when I'm at negative infinity for x up until negative 2, I'm increasing. Sorry, I think I got some glue on my page right there. It's not wanting to write. And then at that point, negative 2, it switches to downhill until I get to positive infinity. So again, with increasing and decreasing, you use the x values to describe where you are because we're moving from left to right. Okay, we are going to now apply what we have just learned to our parent functions.